Going to functions and mappings. A mapping transforms one set of numbers into a different set of numbers. This set is well-defined set. For example, 1, 2, 3, 4, and 1, 2, 2, 3, 4. So this is not a set, but this is a set because it follows the set rules. So this one doesn't follow the set rules, so I can't put this brackets even. Usually we denote mapping with this symbol. Let's say 1, 2, 1, 3, 4, and this is 2, 6, 8. I can tell this is X and this is Y. This is one set of numbers. This is the other set of numbers. And if we are looking for a relationship, okay, 1 to 2, 3 to 6, 4 to 8. This is Y and this is X. And the relationship between Y and X is Y we can express in terms of X, 2X, Y equal 2X. This is functions and mapping. We better discuss like instead of this mapping and functions. Now we are going to discuss about function using mapping. A mapping is a function if every input has only one output. Mapping will become a function if every input has only one output. It means if you put one coin to a machine, you will get only one sweet out. No more 2 or 3 sweet. One coin, one sweet out. In terms of mapping, okay, one sweet, one coin, one sweet, one coin, one sweet, one coin, one sweet. This is also right. One sweet, one coin, one sweet, sorry, one coin, one sweet, one coin, one sweet. Unfortunately, this is the same sweet. It doesn't matter. One sweet, one coin, one sweet, one coin, one sweet. But this doesn't work, this mapping. One sweet, sorry, one coin, two sweet. One coin, two sweet. That doesn't work because the definition is a mapping is a function if every input has only one output. So in the third one, in this one, it violates this rule. We discussed in the year one section in one topic in thoroughly in this one, and this is called one-to-one, and this is called many-to-one, and this is one-to-many. So according to this definition, one-to-one and many-to-one are functions, and one-to-many is not a function. Let's discuss an example for one-to-one. X, Y. If you insert one X, you will get one Y out. For each and every X, you have only one and only Y. Only one Y. So what is the shape? The shape is line. So equation of line is y equal 2x or y equal mx or y equal 2x plus 4 like y equal mx plus c form. X equal minus 2, y equal minus 4. X equal 0, y equal 0. According to this one, y equal 2x. Y equal 2x go in this way. And x equal 2, then y value is 4, and it is 4, it is 6, 1 to 1. Many to 1. When you put minus 2, you will get 4. And when you put 2, you will get again 4. What is the example? The example is y equal x square for this type of graph. When you put minus 2 and when you put 2, when you put minus 2, the answer is going to be 4. And when you put 2, the answer is 4. Because minus 2 is square also 4, 2 is square also, minus 2 is square also 4, 2 is square also 4. Two x values, one output, but minus 2, 4. One input, one output. One input, one output. It doesn't matter, it is same. So this is many to one. So this is also a function. Next one is one to many is not a function. So what is the example for that? When you put one coin, two sweets out, one to many. The example is if you consider a parabola y square equal 4ax. Now I'm going to take one x value. Now one x value, I'll take this is a x bar. So how many y values? This equation is x equal x bar, and we can see that this point x bar y1 and this one x bar y2. For x bar, for one x value, one input we have two output, y1 and y2. So this is where graph and a curve is going to be different. So, and another example is circle. If you take one x value, two y values. If x1, y1, x1, y2. So this is also not a function. So those are the examples for one to many. Now we know that this is not a function because this is one to many. Okay, how can you modify this one to become a function? if I delete this part, then it will become 1 to many. Sorry, 1 to 1. 1 x value, 1 y value. Okay. It will become 1 to 1. How about this one? For this x value, let's say minus 2, there is no any other y value. So it means it's wireless definition. One input, we need one output. Right? When you put a coin and no sweet coming out, so you'll get upset. So the same situation. So we did one modification already. So y square 4ax, we square root. Then we will get y equal plus or minus. I'll put this is okay. I'll write here the modification. So y square equal 4ax form. So I'll put alpha x or alpha square form for calculation, easy calculation. So I'll square root both sides. I'll make it to y. So alpha square root x plus or minus. And I only consider plus positive part, y square root x. So this is the modification. Earlier it was y square 4ax. Then I delete this one. Then this is the form with that modification. But still we have a problem because it is okay for 0 and all those values. But from 0 to negative infinity, those values, this doesn't work. Now what kind of modification we can do? We will erase this part. So we erase this one and then we erase this one. So how do we erase mathematically? So mathematically we can erase. We want to tell real numbers, x belongs to real numbers, but x cannot be less than 0. For all x belongs to real numbers, but not less than all the x less than 0. So what was the modification we did? Right? Don't put the wrong coins. So we have a 20p coin to get a sweet out. Don't put 10 or any other coins. Only 20p's. So likewise, we give a restriction. Likewise, we give a restriction to the x values. Don't put negative x values. Only positive x values. So we restrict the domain. This one also you can tell that instead of less than, for all x not less than 0 or all x greater than or equal to 0, both same idea. Now one to many we modify and we turn into a function. Finally the function is this one. So likewise you may get a question that to identify this occasion or sometime requesting for a modification. When we look at this one, this is look like 1 to 1. But this is not a function. When you put x, 1x, you will get 1y. Sorry, this graph needs to be going to be like this. And 1x, 1y. 1x, 1y. 1x, 1y. 1x, 1y. 1x, 1y. 1x, 1y. So far it's good, but it's not a function. Why? Because on the number line, so they didn't mention anything on this one domain. Usually the domain is appear here. So there is no restriction for anything domain given. In that case, we have to assume that this is the domain is all the real numbers. This is the standard. Now, when we check this one, when x equal to, what is the output? Because each and every input we need only one output, single output. But unfortunately x equal to, what will happen? No sweet. You put a coin but no sweet. Why? Machine will break. Because 1 over, when x equal to 2 minus 2 is 1 over 0. 1 over 0, answer is infinity. We don't recognize infinity as an answer. We don't accept infinity as an answer. So this is 99.99 good, but only 1% is the issue. X equal to. Then how can you make this as a function? So what you can tell, simply y equal 1 over x minus 2 and x, all x is a member of R, or all real numbers except x equal 3. X cannot be, sorry, x cannot be 2. If x is 2, then no output. The output is infinity. We don't accept as output, as an answer. If I write 1 over x minus 3, now you know this is not a function. If you want to make a function, what you need to do, you want to write x not equal to 3. Y equal x minus a. Then for all x belongs to R, for all x belongs to real numbers, but x can't be a. So a is the asymptote, 3 is the asymptote, 2 is the asymptote. Let's discuss in part B that example 7, 8 and 9.